Howdy, in this video we'll be dealing with section 2.4 of First Course in Mathematical Logic by Patrick Suppes and Shirley Hill. It's more about parentheses. Let's get started. Remember that parentheses allow us to group things in a molecular sentence. For example, proposition 1 and 2 state different things precisely because they have different groupings. Proposition 1 has the or connective outside the parentheses, thereby making it the dominant or strongest connective. And by making it the dominant or strongest connective, overall, proposition 1 is a disjunction. Whereas in proposition 2, the and connective is outside the parentheses, thereby making it dominant or strongest of the connectives, and so proposition 2 as a whole is a conjunction. And precisely because it is a conjunction, we can engage in simplification with proposition 2. That is, we could immediately infer that therefore the atomic sentence P is the case, and that therefore the molecular sentence Q or R is the case. Whereas we cannot, in proposition 1, engage in simplification. It's not a conjunction, it's a disjunction. We cannot, so to speak, pull out P and Q from those parentheses. Let's look at exercise 10 from page 78, part A. Does the sentence not Q and R differ in meaning from the sentence not parentheses Q and R, close parentheses? If so, can you explain the difference in your own words? Well, certainly they're not logically equivalent. They're different because the negation is being applied in a different way. Obviously, in the first sentence, we have Q negated. Q is not the case, or we might say Q is false, whereas in the second sentence, Q and R is negated. That is, Q and R is not the case, or Q and R is false. Also, notice that in the first sentence, the dominant sentential connective is and, whereas in the second sentence, the dominant sentential connective is not. But let's consider more precisely what the second sentence is saying. For example, in basic algebra, we know that you can distribute a negative side. Could something similar happen here? That is the sentence not, parentheses, Q and R, close parentheses, identical with not Q and not R? Well, let's think about it. On the left-hand side, we have Q and R, and that, so to speak, is being collectively denied. So we have not, parentheses, Q and R, close parentheses. That is, Q and R are not both true. Is that logically equivalent to, or by necessity entail, that Q is false and that R is false? Well, certainly not. Q and R are not both true. So at least one is false. One of those options is false. Q may be false or R may be false. Or both may be false, but it doesn't necessitate that both are false. So therefore, they're not equivalent statements, not at all. We can also consider this in terms of an example. So let's pretend we knew for a fact in the concrete that Q is true and that R is false. So given this, would this be, logically compatible with this molecular sentence? Again, the molecular sentence tells us that Q and R are not both true. Well, yeah, it fits. After all, R is false. But notice that this concrete example is not compatible with this right-hand side. Okay? It contradicts it. But we also know that this concrete example fits the left-hand side. So again, we know that the left-hand side and the right-hand side are not logically identical. They're not logically equivalent. So with that in mind, we can answer the question this way. The first sentence, we know only R is the case and Q is false. But in the second sentence, we know at least one is false. It could be Q or it could be R, or it could be both. So the first sentence and the second sentence definitely say something different. So let's move on to part B. And let me erase some of this. All right. So B tells us, suppose our example sentence had been symbolized in the following way, parentheses, not Q and R, close parentheses. Does this sentence have the same meaning as either example in exercise A above? Well, this is a trivial question, it's obvious even. The answer is yes. Okay, that is, not Q and R is in fact logically identical or equivalent to parentheses not Q and R. And in this case, the parentheses are entirely superfluous. They're not necessary. They're not needed. So why even write it that way? You would only need parentheses if this was part of a larger molecular sentence. But it's not. It's all by itself. But anyhow, they're definitely identical. And we could, if we wanted to, just add additional, parentheses, right? They would still remain identical. So, all right, part C. Suppose we are given as a first premise the sentence, if P, then Q or R. The second premise of the sentence is not, parentheses, Q or R, close parentheses. Can you derive a conclusion from these premises? Could you remove the parentheses from the second premise and derive a conclusion? Explain your answer. Well, in the first part, we definitely have a modus tollens situation. So the first premise is if P, then Q or R. Second premise, we have not, parentheses, Q or R. So we can therefore infer that P is not the case. By modus tollens, the sentences 1 and 2. So the second premise is denying the consequent of our first premise, so we could thereby deny the antecedent. Now, if we remove the parentheses from the second premise, we couldn't deny the consequence, so we couldn't derive anything. We would be stuck, or we would be done. That's it. Nothing more could be said. So it's pretty clear that removing the parentheses makes a world of difference, and they're not logically equivalent. Okay, so not parentheses Q or R is not identical with not Q or R. Flipping to page 79 of the Suppes and Hill textbook, for each of the following sets of premises, a conclusion is stated. In some cases, the conclusion follows logically only if parentheses are added to show the proper grouping. Add parentheses if needed to make the conclusion valid. For example, with number 1, the premise is a conditional overall. And note, I'm using the Suppes and Hill conventions here, and you should be too. So implicitly, you can think of the parentheses as right here, because it is a conditional, if P, then Q and R. The dominant sentential connective is the if-then, but there's no way to derive the conclusion R validly from a conditional. So what's going to happen is we're going to have to make this a conjunction. So we could put parentheses around the if P, then Q, and then by simplification we can get R. However, other textbooks, you can only simplify the very first term of a conjunction, so you would have to do the commutative rule first. You would have to say R and parentheses if P, then Q. That's by the commutative rule, and then by simplification you can get that R. What about number 2? We have the premise if P, then Q and R. By default, the if then is the strongest sentential connective, so we can think about this as implicitly having parentheses right here. Then we have the premise not Q and R, conclusion not P. Clearly that's invalid. We want to deny the consequence, so we're going to have to put parentheses around this Q and R, and then through modus tollens we can get the not P. For number 3, we have Q and P or S. We have the conclusion Q, so we're going to have to make that a conjunction, the premise. Thus, we'll put parentheses around the P or S. And that conclusion is valid now by simplification. For number 4, we have premise if P, then Q and S, premise P, therefore Q and S. Well, that's already valid by the modus ponens inference, and implicitly at least there are parentheses around here. Okay, we have a lot of work ahead. Section 2.5, further rules of inference. We got to cover the law of addition, the law of hypothetical syllogism, we got De Morgan's law, etc., etc. So a lot of work ahead. I'm probably going to have to break up section 2.5 into parts. But that's coming up next. Thanks for watching. I'll see you soon.